Physics, and this is for HSC, CBSE, and IC students, class 11 Physics. The chapter is gravitation, and today this is class number P68, problems of orbital velocity, escape velocity, and gravitational energy. Problems of orbital velocity, escape velocity, and gravitational energy from chapter 8, unit 6, gravitation. These are some of the important problems. The first problem is calculate the escape velocity of a body from the surface of the Earth. Earth, you write. Find the escape velocity of a body from the surface of the Earth given radius of Earth is 6.38 into 10 raised to 6 meter. So escape velocity, we have two different formula. The first one is in terms of small g, root of rg. R is the radius and g is the acceleration due to gravity, and we give the value, that is escape velocity using root of 2 into 6.38 into 10 raised to 6 into 9.8 root, that is 11.18 into 10 raised to 3 meter per second, and 10 raised to 3 we can write as kilometer. 10 raised to 3 meter is kilometer. So V is equal to 11.18 kilometer second raised to minus 1. Or we can simply remember V is 11.2 kilometer per second. Escape velocity on the surface of Earth is 11.2 kilometer per second. Next problem. Determine the escape velocity of a body from the moon. Take moon to be a uniform sphere of radius 1.74 into 10 raised to 6 meter and mass is 7.36 into 10 raised to 10 raised to that is given 10 raised to 22 kilogram. Mass of moon is 7.36 into 10 raised to 22 kilogram. And capital G is 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. But moon is escape velocity kandupidikkananu. So moon escape velocity Vm, V moon, escape velocity moon, root of 2 gm by r, or gmm by rm. Mm is the mass of moon and rm is the radius of moon. Mass of moon mm is 7.36 into 10 raised to 22 kilogram. And radius is also given 1.74 into 10 raised to 6 meter. G is 6.7 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Put this in the equation. Vm is root of 2 gm by r or 2 g mm by rm. That mooninte velocity, escape velocity formula. Our value would root of 2 into g, 6.67 into 10 raised to minus 11 into 7.36 into 10 raised to 10 raised to 22 by 1.74 into 10 raised to 6, the value. The answer is 3.375 kilometers second raised to minus 1. 3.375. Next problem. Jupiter has a mass 318 times that of Earth, and it is 11.2 times the radius, 11.2 times the radius of Earth. Estimate the velocity of a body. Velocity of a body from Jupiter surface, given that the escape velocity from Earth is 11.2 kilometers second raised to minus 1. അപ്പോൾ ഈ ചോദ്യം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ, അത് എർത്തിലെ എസ്കേപ്പ് വെലോസിറ്റി തന്നിരിക്കുകയാണ്, ജൂപ്പിറ്ററിലെ എസ്കേപ്പ് വെലോസിറ്റി കണ്ടുപിടിക്കാനാണ്. അവയുടെ മാസ് റേഷ്യോ തന്നിട്ടുണ്ട്, അതുപോലെ റേഡിയസ് റേഷ്യോയും തന്നിട്ടുണ്ട്. ഇപ്പോൾ ഇവിടെ താഴെ വ്യക്തമായി എഴുതിയിട്ടുണ്ട്. Mass of Jupiter MJ 318 times mass of Earth, where M is the mass of Earth, MJ is the mass of Jupiter. Radius of Earth, radius of Jupiter RJ 11.2 RE. RE is the radius of Earth. Escape velocity from Earth VE root of 2G ME by RE. And that we know it is equal to 11.2 into 10 raised to 3 meter second raised to minus 1. The kilometer per second we convert into meter per second. So it is 11.2 into 10 raised to 3 meter second raised to minus 1. For Jupiter, Vj is equal to root of 2 root of G Mj by Rj. And we substitute the values in terms of Earth. ജുപ്പിറ്ററിൻ്റെ മാസം ജുപ്പിറ്ററിൻ്റെ മാസം അതിൻ്റെ റേഡിയസും എർത്തിൻ്റെ മാസിലും റേഡിയസിലും എക്സ്പ്രസ് ചെയ്യുക. ദാറ്റ് ഈസ് വി ജെ ജി ഇൻറ്റു റൂട്ട് ഓഫ് ജി ഇൻറ്റു 318 ME by 11.2 RE inside root. And 318 by 11/2 we write a separated root, and in another root sign we write GME by RE, and that you know GME by RE is escape velocity of Earth. So there we can write B escape, which is 11.2 into 10 raised to 3 multiply, we get V J, the escape velocity from Jupiter is 59.68 into 10 raised to 3 meter second raised to minus 1. Next problem. Find the orbital velocity of an artificial satellite of Earth in an orbit close to Earth. എർത്തിനോട് ചേർന്നുള്ള ഒരു ഓർബിറ്റിൽ ഒരു ആർട്ടിഫിഷ്യൽ സാറ്റലൈറ്റിൻ്റെ വെലോസിറ്റി, അതായത് ഓർബിറ്റൽ വെലോസിറ്റി കണ്ടുപിടിക്കാനാണ്. അപ്പോൾ R is 6400 kilometer. Orbital velocity VO is root of GR for a close orbit. That is first cosmic velocity. You know it is first cosmic velocity, the orbital velocity in a close orbit of Earth. That is root of 9.8 into radius of Earth 6.4 into 10 raised to 6. And that is VO is equal to radius of Earth is 6.4 into 4 into 10 raised to 6. So 7290 meters second raised to minus 1. Next question, what is the orbital velocity of an artificial satellite revolving around the Earth at a height of 100 meter? 100 meter പൊക്കത്തിലാണെങ്കിൽ എന്താണ് എർത്തിൻ്റെ ഒരു സാറ്റലൈറ്റ് ഓർബിറ്റ് വെലോസിറ്റി? R is 6400 kilometer for Earth. That is 6.4 into 10 raised to 6 meter. കിലോമീറ്റർ മീറ്റർ ആക്കാനായിട്ട് നമ്മൾ 3 സ്ഥാനം ചേർക്കണം. അപ്പോൾ 6.400 into 10 raised to 3 എന്ന് വരും. അപ്പോൾ 6.4 into 10 raised to 6 meter. G 9.8 meter second raised to minus 2. So you put the values, we get V orbital is root of 9.8 into 6400 into 10 raised to 3 square. The formula is GR square by R. GR square by R. The formula also we can write in that manner. You look here, the formula we can write as orbital velocity, that is GM by R. GM is GR square. GR square by small r. Small r is the two distance, the radius of Earth and height should be added. So it is 6500 into 10 raised to 3. So the formula is G root of G capital R square by small r. You know the orbital has that formula is not written there. You remember the formula. BO is equal to root of GM by small r. Small r is capital R plus H. And the capital GM is small g into capital R square. We have studied small g is gm by r square, capital Gm by r square. So gm, if we find, we get gr square. So the formula we can write as gr square by small r. Small r is capital R plus h, which will come here as 6400 plus 100 kilometer. That is 6500 kilometer. That is 6500 into 10 raised to 3 meter. That value is put here. We get 70. The answer is 58.3 meter per second. Next problem. Calculate the height above the earth at which a geostationary satellite is orbiting the earth. Radius of earth is given, mass of earth is given, g is also given. ആ എർത്തിൻ്റെ ഒരു ജിയോസ്റ്റേഷണറി സാറ്റലൈറ്റ്, ഒരു സിങ്ക്രോണസ് സാറ്റലൈറ്റ്, അതിൻ്റെ പീരിയഡ്, അതിൻ്റെ ഹൈറ്റ് കണ്ടുപിടിക്കാനാണ്. ഓർക്കണം, അത് ഈ ചോദ്യം കാണുമ്പോൾ തന്നെ ഉത്തരം ഓർത്തിരിക്കാവുന്നതാണ്. ഹൈറ്റ് ഏതാണ്ട് അപ്രോക്സിമേറ്റ് പറയുകയാണെങ്കിൽ അത് 36,000 കിലോമീറ്ററാണ്, 36,000 കിലോമീറ്റർ. ദ ഹൈറ്റ് ഓഫ് ജിയോസ്റ്റേഷണറി സാറ്റലൈറ്റ് ഓഫ് എർത്ത് ഈസ് അബൌട്ട് 36,000 kilometers. So period of satellite, earth satellite is T, 24 hours. That is converted to second by multiplying it by 60 into 60, 86,400 second. And the formula is gmm by r square. The attractive force is centripetal force, mr omega square, or mr into omega is 2 pi by t the square, mr into 4 pi square by t square. From this we can find the period. If we find the period, we get t is equal to 2 pi into root of r cubed by gm. 2 pi into root of r cubed by gm. Root of r cubed by gm. R cubed by gm is in a single root. And if you write as r cubed, we get a gm t square by 4 pi square. So r is gm t square by 4 pi square is to 1 by 3. Put the values. Put the values here. G constant is put. M is mass of earth 6 into 10 raised to 24 into t square, 86,400 square by 4 into pi square, 3.14 square, the whole raised to 1 by 3. We get 4.2312 into 10 raised to 7 meter. And small r is capital R plus h. So height h is small r minus capital R, 4.2312 into 10 raised to 7 minus 6,400 into 10 raised to 3. You subtract it. When we subtract, you know how to subtract. Take a common factor and subtract. Take a power 10 raised to 7 out and then subtract. Or 10 raised to 3 out and then subtract. We get 35,912 into 10 raised to 3. That is 35,912 kilometer, which is approximately 36,000 kilometers. This is the answer. അപ്പോൾ ആ പവർ കുറക്കാൻ പഠിക്കണം. പവർ കുറക്കാനായിട്ട് നമ്മൾ പിന്നെ ഒരു 6.400 ഇൻറ്റു 10 raised to 3, അതിനെ നമ്മൾ 0.64 ഇൻറ്റു 10 raised to 7 എന്ന് എഴുതാം. 0.64 ഇൻറ്റു 10 raised to 7 എന്ന് എഴുതാം. എന്നിട്ട് 10 raised to 7 കോൺഫാക്ട് എടുത്താൽ മതി. എന്നിട്ട് കുറക്കാം. കുറച്ചിട്ട് ബാക്കി സ്ഥാനം മാറ്റുമ്പോൾ ഈ താഴെ കാണുന്നത് കിട്ടും. നെക്സ്റ്റ് ക്വസ്റ്റ്യൻ. An Earth satellite makes a complete revolution around the Earth in 120 minutes. If the orbit is circular, calculate the height of satellite above the Earth. Radius of Earth is 6,400 km, G 9.8. So here small r is gmt square by 4 pi square is to 1 by 3. Here gm is gm, g and m is m not given, g and r are given, and gm, capital Gm is small g into r square. So that we put here, r is gr square into t square by 4 pi square is 1 by 3. Put the values. Put the values in their appropriate place. The time period is 120 minutes, that we convert into second, that is 70 to 100 second. So when we put those values, we get r is 9.8 into 6,400 into 10 cubed, the whole raised to 2 into 70 to 100 square by 4 into 3.14 square, the whole raised to 1 by 3. That you simplify using a calculator, we get the answer as r is equal to the total height from the center of the earth is equal to 8.081 into 10 raised to 6 meter. And small r is capital R plus h. H is small r minus capital R. 8081 into 10 raised to 3 minus 6400 into 10 raised to 3. Take count factor and subtract, we get 1681 into 10 raised to 3 meter. Answer. Next question. Find the mass of Earth from the following data. Find the mass of Earth from the following data. The period of lunar orbit of around the Earth is 20. Period of the orbit. It's a lunar orbit. Sorry, it is a lunar orbit. Lunar orbit. ചന്ദ്രൻ്റെ ഓർബിറ്റിൻ്റെ കാര്യം പറയുന്നത്. ദ പീരീഡ് ഓഫ് ലൂണർ ഓർബിറ്റ്, ചന്ദ്രൻ കറങ്ങുന്നതാണ്, മൂൺ കറങ്ങുന്നതാണ്. Around Earth is 27.3 days and radius of orbit is 3.9 or power 10 raised to 5 kilometer. G is given. The force of attraction between Earth and the Moon provides the necessary centripetal force. So we write the same equation, the previous equation. Or we can write an equation for the period, that is T is 2 root of R cubed by GM. R cubed by GM we can write that is period expression. R cubed by GM, where R is the radius of the orbit, and from this we can calculate M, mass of Earth, R square and 4 pi square by GT square. Radius of lunar orbit, R is 3.9 into 10 raised to 3 kilometer, 3.9 into 10 raised to 6 meter. Lunar period, it is 27.3 days. Chandra Masam, 27.3 days. Days we convert into second. 1 day is 86,400 second. 86,400 second. Therefore, mass of Earth, M Earth question mark. That is equal to 4 pi square by G R square by T cubed. T square, R cubed by T square. R cubed by T square. So you substitute the values, we get 6.318 into 10 raised to 24 kilogram. You remember the mass of Earth we take as 6.4 into 10 raised to 24 kilogram. And here it is 6.318. Next question. Find the mass of Sun from the following data. The mean orbital radius of Earth around the Sun is 1.5 into 10 raised to 8 kilometer. സൂര്യൻ്റെ മാസം കണ്ടുപിടിക്കാനാണ്. അതിനാ പീരിയഡ് ഇക്വേഷൻ തന്നെ എടുത്താൽ മതി. T is 2 root of R cubed by GM. R എന്ന് പറഞ്ഞാൽ എർത്ത് സൺ ഡിസ്റ്റൻസ് ആണ്. എർത്ത് സൺ ഡിസ്റ്റൻസ് സ്മോൾ ആർ. അപ്പോൾ ഓർക്കണം, സൂര്യൻ്റെ മാസ് 2 into 10 raised to 30 kilogram ആണ് അതിൻ്റെ വാല്യൂ. The mass of Sun is 2 into 10 raised to 30 kilogram. So the answer will work out as 2 into 10 raised to 30. So here also we write a period, or we can find a period. T is 2 root of R cubed by GM. In that manner we can write. And if we find M of Sun, 4 pi square R cubed by GT square, where R is the Earth Sun distance, which is also known as the astronomical distance. That word is not given here. Astronomical distance, which is equal to 1.5 into 10 raised to 8 kilometer, equal to 1.5 into 10 raised to 11 meter. Period is 365 and 1/4 days. That we convert into second. 365.25 into 86 second. Substitute the values. We get M is 2.006 into 10 raised to 30 kilogram. So you, as a memory aid, you can remember mass of Sun is about 2 into 10 raised to 30 kilogram. Next question. Saturn year is 29.5 times the Earth year. Saturn ശനിയുടെ വർഷം സൂര്യന് ചുറ്റും കറങ്ങാനുള്ള സമയം. Saturn year is 29.5 times the Earth year. How far is the Saturn from the Sun if Earth is 1.5 into 10 raised to 8 kilometer away from the Sun? അപ്പോൾ എർത്ത് സൺ ഡിസ്റ്റൻസ് ഉണ്ട്, നമുക്ക് എർത്ത് സറ്റേൺ ഡിസ്റ്റൻസ് കാണണം. So Kepler's theory law, T square proportional to R cubed. For Saturn, T square proportional to R Saturn square cubed. For Earth, T is for Saturn, T is 29.5 years, and we have to find R Saturn. For Earth, T square proportional to R cubed. T Earth is 1 year and R Earth is 1.5 into 10 raised to 8 kilometer. You put the values. So when we put the values, we get R Saturn square by R Earth square. T Saturn square by T Earth square is R Saturn cubed by R Earth cubed. So from this we find R Saturn is equal to T by T raised to 2 by 3 into R Earth. Put the values. We get 29.5 by 1 raised to 1 by 3 raised to 2 by 3 into 1.5 into 10 raised to 8. We get 1.432 into 10 raised to 9 kilometer. Answer. Next problem is a very important problem. The energy of satellite. The gravitational potential energy and kinetic energy of satellite. That is a question, very important question. A geostationary satellite orbits the Earth at a height of nearly 36,000 kilometers from the surface of Earth. What is the potential due to Earth's gravity at the site of the satellite? Take potential energy at infinity to 0, mass of Earth is given, radius is given. So M is 6 into 10 raised to 24 kilogram, R is 6400 into 10 raised to 3 meter for Earth, G is given, height H is 36,000 into 10 raised to 3. The gravitational potential is V is equal to minus Gm by small r or minus Gm by r plus h. Small r is r plus h. So you substitute the value, we get minus 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 by 6400 into 10 raised to 3 plus 37,000 into 10 raised to 3. Simplify. We get a minus 9.338 into 10 raised to 7 joule kg raised to minus 1. That is the unit of gravitational potential. Joule kg raised to minus 1. Next problem, this is also important. A satellite orbits Earth at a height of 500 km from the surface. Compute its A kinetic energy, B potential energy, and C total energy. Mass of satellite 300 kilogram. Mass of Earth 6.0 into 10 raised to 24. Radius of Earth is 6.4 into 10 raised to 6 meter. G is given. Write your answer. After the Earth when the Earth were to shrink suddenly to half its value, half its size. അതായത് ആദ്യം നമ്മൾ പൊട്ടൻഷ്യൽ എനർജി, കൈനറ്റിക് എനർജി, ടോട്ടൽ എനർജി കാണണം. ഈ എർത്ത് പകുതിയായിട്ട് ഷ്രിങ്ക് ചെയ്താൽ, ചുരുങ്ങിയാൽ എന്തായിരിക്കും ഈ വാല്യൂസ്? എർത്ത് ചുരുങ്ങുമ്പോഴുള്ള വാല്യൂസ് കണ്ടുപിടിക്കണം. ദ ഓർബിറ്റൽ വെലോസിറ്റി ഓഫ് സാറ്റലൈറ്റ് അറ്റ് ഹൈറ്റ് ഈസ് ഗിവൺ ബൈ റൂട്ട് ഓഫ് Gm by r plus h. അത് kinetic energy, you would directly apply the kinetic energy formula, that is mgm by 2r. mgm by 2r നമ്മൾ പഠിച്ചതാണ്. 2 small r is r plus h. So mgm by 2 into r plus h, that is kinetic energy that we calculate. Put the values. mg by 2r, all values are given, substitute the values, simplify. Either denominator will come 2 into 6.4 half, mg by 2r, that is 2, into 6.9 into 10 raised to 6. You copy down the values. Then we get 8.7 into 10 raised to 6, 9 joule. 10 raised to 9 joule. Now potential energy. Potential energy is minus mgm or gmm by small r. അല്ലെങ്കിൽ ഓർക്കണം, ഇത് കൈനറ്റിക് എനർജിയുടെ ഇരട്ടിയാണ് മൈനസ് ആണ്. അങ്ങനെ ഓർത്താലും മതി. കൈനറ്റിക് കാൽക്കുലേറ്റ് ചെയ്യേണ്ട, നമ്മൾ പഠിച്ചതാണ്. യു ഈസ് ടോയ്സ് ദ വാല്യൂ ഓഫ് കൈനറ്റിക് എനർജി ബട്ട് മൈനസ്. ഇവിടെ വാല്യൂസ് എഴുതിയിട്ടുണ്ട്, അതൊക്കെ പാർത്താൻ വേണമെങ്കിൽ, പക്ഷേ അതിൻ്റെ ആവശ്യമില്ല. ശരിക്കും പറഞ്ഞാൽ നേരിട്ട് ഉത്തരത്തിലേക്ക് പോവാം. 8.7ൻ്റെ ഇരട്ടി എടുക്കണം, ഡബിൾ എടുക്കണം. അപ്പോൾ അതൊരു ഡബിൾ എടുക്കുക, കിട്ടുന്ന ഉത്തരം -17.4 ഇൻറ്റു 10⁻⁹ ജൂൾ, മൈനസ് സൈൻ. ടോട്ടൽ എനർജി നമുക്കറിയാം, അത് ടോട്ടൽ എനർജി കൈനറ്റിക് എനർജിക്ക് തുല്യമാണ്. മൈനസ് സൈൻ ഇട്ട് കൊടുക്കണം. ടോട്ടൽ എനർജി കൈനറ്റിക് എനർജി തുല്യം മൈനസ് ഇട്ട് കൊടുക്കണം. -8.7 ഇൻറ്റു 10⁻⁹ ജൂൾ. അതാണ്. ഇനി എർത്ത് നേരെ സൈസ് റേഡിയസ് പകുതിയായാൽ, റേഡിയസ് 6.4 ഇൻറ്റു 10⁻⁶/2 ആകും. അപ്പോൾ 3.2 ഇൻറ്റു 10⁻⁶ ആകും. ആ കേസിൽ ഇപ്പോൾ 6ആണല്ലോ താഴെ വരുന്നത്. അപ്പോൾ അങ്ങനെ വരുമ്പോൾ പകുതി ആകുമ്പോൾ എന്ത് സംഭവിക്കും? ഹെൻസ് കെ ഇ പി ആൻഡ് ടി വിൽ ഇൻക്രീസ്. അവ മൂന്നും കൂടും എന്നർത്ഥം. കാരണം 6 താഴെ വരുന്നത് mgm/2r, mgm/r, 6 താഴെ വരുന്നതുകൊണ്ട് ആ റേഡിയസ് പകുതി ആകുമ്പോൾ ഇവയെല്ലാം അങ്ങോട്ട് കൂടും. One more problem. Find the period of revolution of a satellite revolving the Earth at a height of 200 meter. Radius of Earth is given. So we know T is 2 pi in the root of r cubed by gm. And gm we can write as gr square. When we put the gm is small g into r square, we can take a g outside. So 2 pi by r into root of r cubed by gm. R cubed by gm formula. So here r is given, capital R is given, small r is given, because h is given 200 into 200 kilometer, 200 into 10⁻³ meters. Substitute the values, we get 5310 second. That is the answer. That is all with your 68th class. We continue our topic with more questions from gravitation. Next class.